Welcome to the next video of Section 3, Player Input. In the previous video, we've learned how to create a player object. In this video, we'll see more about player input. The player object is now created in the scene, configured with both rigid body and collider components. However, this object doesn't respond to player controls. In a twin-stick shooter, the player provides input on two axes and can typically shoot a weapon. This often means that keyboard WASD buttons guide player movements up, down, left and right. In addition, mouse movement controls the direction in which the player is looking and aiming, and the left mouse button typically fires a weapon. This is the control scheme required for our game. To implement this, we'll need to create a player controller script file. Right-click on the scripts folder of the project panel and create a new C# script file named playercontroller.cs. In the playercontroller.cs script file, this code should be featured. The player controller class should be attached to the player object in the scene. Overall, it accepts input from the player and will control the movement of the spaceship. The awake function is called once the object is created at the level start. During this function, two components are retrieved, namely the transform component for controller player rotation and the rigid body component for controller player movement. The transform component can be used to control player movement through the position property, but this ignores collisions and solid objects. The rigid body component, in contrast, prevents the player object from passing through other solids. The fixed update function is called once on each update of the physics system, which is a fixed number of times per second. Fixed update differs from update, which is called once per frame and can vary on a per second basis as the frame rate fluctuates. If you ever need to control an object through the physics system using components such as rigid body, then you should always do so in fixed update and not update. This is a Unity convention that you should remember for best results. The input.getAxis function is called on each fixed update to read the axial input data from an input device, such as a keyboard or gamepad. This function reads from two named axes, horizontal, left-right, and vertical, up-down. These work in a normalized space of -1 to 1. This means that when the left key is pressed and held down, the horizontal axis returns to -1. And when the right key is pressed and held down, the horizontal axis returns 1. A value of 0 indicates that either no relevant key is being pressed or both left and right are being pressed together, cancelling each other out. A similar principle applies for the vertical axis. Up refers to 1, down to -1, and no key presses relates to 0. More information on the getAxis function can be found online in the Unity documentation at this site. The rigidbody.addForce function is used to apply a physical force to the player object, moving it in a specific direction. AddForce encodes a velocity, moving the object in a specific direction by a specific strength. The direction is encoded in the move direction vector, which is based on player input from both the horizontal and vertical axes. This direction is multiplied by our maximum speed to ensure that the object travels as fast as needed. For more information on AddForce, see the online Unity documentation at this site. The camera.screen-to-world-point function is used to convert the screen position of the mouse cursor in the game window into a position in the game world, giving the player a target destination to look at. This code is responsible for making the player look at the mouse cursor always. However, as we'll see soon, some further tweaking is required to make this code work properly. For more information on screen-to-world points, see the online Unity documentation at this site. Awesome! In this video, we've successfully learned about player input. In the next video, we'll learn how to configure the game camera.